Hello, welcome to the second video on factorizing quadratics. In this video, we're going to be looking at the extra details you need to watch out for when factorizing certain quadratics in particular scenarios. If you want help with knowing how to factorize quadratics in general, in normal scenarios, then do look at my previous video on this topic, for which there is a link appearing on the screen right now. But if you are continuing with what we're looking at today, let's start off by looking at how do you factorize a quadratic with no constant term? Well, for instance, we could have the quadratic that's got an x squared term involved and a quadratic that's got an x term involved, but we're talking about the situation where there's just no number on the end, no constant term. Well, one way of factorizing quadratics of this type is to almost treat them like what I call almost old school factorizing. I'm talking about those situations where you look at the algebra you have and you try to factor out the highest common factor by looking at each term individually and deciding what all of the terms can be divided by. So therefore, in this case, you'd look at all those terms, you'd first decide, is there a number that all those terms can be divided by? In this case, no, because we've got one lot of x squared, and therefore the highest common factor numerically is 1. But if there was a number in front of the x squared that meant there was a bigger number, factorize that out as well. And then also looking at the algebra and deciding what's the biggest thing both those bits can be divided by, the x squared and the x. Well, the biggest thing they can both be divided by is an x. And that will leave us with some brackets, and inside those brackets we'll have what we get if you divide both those things by x. So x squared divided by x is x, 5x divided by x is 5, and there you go, we've factorized it. So that's one way of looking at it. But there is a second way you could look at it. You could choose to look at this as if it is a normal quadratic, x squared plus 5x, but with the constant term effectively of plus 0. You obviously wouldn't bother normally writing that plus 0, and I'm just writing it now just to illustrate what I'm trying to say. Because now we've written it or viewed it as a normal quadratic, you can do the same usual tricks that we do to solve any normal three-term quadratic. So therefore, as this is a quadratic with just a 1x squared, therefore we are just simply looking for two numbers that multiply together to make the number on the end and add together to make the number that's in front of the x term, which is in this case a 5. Now, because we're looking for two numbers that multiply together, to make 0, that's important because it means that at least one of those two numbers has got to be a 0. So therefore, that's narrowing down our options straight away. But is the second number a 0 as well? Well, no, because of the fact we're also looking for two numbers that add together to make 5. And as the first number was 0, that means the second number has to equal 5 in order to make sure that the two numbers add together to make 5. And the good news is that doesn't cause a problem for the multiply bit because anything times by 0 is 0, so even though it's 5 times 0, that still multiplies together to make 0, which is what we needed. So therefore the quadratic factorizes to x plus 0 and x plus 5, the two numbers just going inside the brackets. However, this is a weird way of writing it and a stupid way of writing it almost. Because there's no point writing a plus 0. So in reality, this is x plus 0, which is just x, hence why this would be rewritten as just x, lots of x plus 5. So this is still the final way you would write the answer. There you go. So that's how you deal with quadratics with no constant term. But what happens if it's not the constant term that's missing? What happens if it's that middle term with the x that's not appearing in your quadratic? Well, this is a scenario that we call difference of two squares, potentially. So first of all, what sort of example could we be looking at? We could be looking at the situation x squared minus 9. You can see there's no x term. Well, there's two ways you can look at these sort of quadratics as well. One of them is the aforementioned difference of two squares sort of approach, which is where you realize that both the first number, or the first thing I should say, appearing in your quadratic and the last thing appearing in your quadratic are both things that are squares. The first thing is x squared, and then the 9 is secretly 3 squared. And then the other thing you're looking out for is the fact that there's a minus sign in between them. There's got to be a minus sign in between them for this trick to work. Hence why it's called difference of two squares, because the word difference is related to minus, basically taking away. If this is the case, if you've got a difference of two squares situation like we do here, it's actually very easy to factorize. You instantly know in your two pairs of brackets, you're going to have the two things that are appearing in your quadratic without the squareds appearing there. So instead of x squared, it's just an x appearing in both brackets, and instead of a 3 squared, it's just 3 appearing in both brackets. And then what's going to go in between the two things inside both of the brackets is one of them is going to have a plus and the other one's going to have a minus. And that'll happen every single time for difference of two squares. So that'll even happen on situations where the x squared bit's a bit more complicated. Let's say you had a 16x squared minus 25. Well, in that case, you realize that the first thing is secretly 4x all squared, because 4 squared is 16 and x squared is x squared. So therefore 4x all squared is 16x squared. And then the 25 is secretly 5 squared. So again, we've got difference of two squares because it's something squared take away something else squared. So that means inside the brackets, I know it's going to be the things without the squareds, and then it's going to be one of the things with the plus and one of the brackets with the minus inside. So there you go, that's difference of two squares. However, if you do forget that trick, I do recommend you do remember it, but if you do forget it, not the end of the world, because there's another way you could look at it. You could view it again like a normal quadratic. Instead of viewing x squared minus 9 as x squared minus 9, you could view it as x squared plus 0 lots of x, which again is a stupid way to write it, because you know, writing 0 lots of x is trivial, and therefore that as notation is just bad. But anyway, if you view it secretly like this, then you realize, again, it's just like factorizing a normal quadratic. You're looking for two numbers that multiply together to make minus 9. You're looking for two numbers that add together to make 0. Now, if you're looking for two numbers to add together to make 0, you know they are the same number as each other, but just one of them's got a plus in front of it, the other's got a minus in front of it. So looking for two identical numbers that are just, you know, with different signs in front of them. And then we're thinking, okay, those two numbers also have to multiply together to make minus 9. So that's why you know it's 3 and minus 3, because those are the two numbers that satisfy both those criteria. And that's what then leads to you knowing that it factorizes to x plus 3, x minus 3. So there you go. You can still factorize it even if you don't remember that trick. And the third situation we're going to be dealing with is what happens if the coefficient of x squared is a negative number. Because you might remember in my previous video on factorizing, I suspiciously left that case out, and that's partly because I knew I was going to be dealing with it in this particular video. So what have you got to do? Well, you've just got to do an extra step on top of what you would normally do, which is you're first going to factorize minus 1 out of the entire quadratic. Note, I am saying factorize, don't just divide it or cancel it out or something weird like that. We still have to take account of that minus sign in there, but it's just we're going to temporarily separate it out to make the calculations a bit easier. And then whatever quadratic we're left with after doing that initial factorization will just be a quadratic that will now have a positive value of a in front, allowing us to just treat it like normal, which will make life a lot easier. So for instance, what happens if we've got the example minus x squared plus 5x minus 6? We note, of course, because there's that minus sign in front, it's effectively like we've got minus 1 lots of x squared. So I am going to factorize minus 1 out of this quadratic to begin with because it's a negative number out the front. But just factorize minus 1 out, even if it was minus 2 out the front, it's just the minus 1 I'm factorizing out the front. So therefore I put a minus sign, open brackets, and then what goes inside the brackets is if I'm dividing by minus 1, but in reality I'm factorizing. So minus 1 x squared divided by minus 1 would just be a positive 1x squared. Positive 5x divided by minus 1 would be negative 5x. And then minus 6 divided by minus 1 would be positive 6. Brilliant. Now I'm in a situation where the quadratic inside these brackets is now a quadratic with a positive amount of x squareds, so therefore I can now factorize that just using whatever method I would usually be using, which for this one, of course, is just the classic see what two numbers multiply together to make the number on the end, what two numbers add together to make the number in the middle. So therefore that, of course, is -2 and -3. So overall, it's factorizing to minus, then x minus 2 and x minus 3. You do have to remember to still include that minus sign out the front. That is part of the factorizing process. Cool. The last thing we're going to be dealing with in this video is dealing with a kind of quirk that some students start to spot when solving quadratics and factorizing quadratics, and they start to think that they've spotted a trick. Either their teacher has forgotten to tell them, or is purposely hiding from them, or perhaps that they're thinking the teacher doesn't know about. Or even there might be some teachers who do teach this trick, but then the problem is some students forget some aspects of it, and then it all goes wrong, and the student just doesn't understand why. What I'm talking about is the link between the solutions you get when solving a quadratic that's been set equal to 0, and the brackets you get when you factorize that quadratic. For instance, if we're factorizing x squared minus 5x plus 6, you get x minus 2, x minus 3. But the solutions you get from solving this quadratic are x equals 2, x equals 3. Now, because you don't have to use factorizing to solve a quadratic, there are other methods, and also because there's calculators that can solve quadratics for you, some students sometimes try to start using the solutions to a quadratic equation to be able to work backwards to find what the factors are. And at first glance, it appears like that's very easy to do because we've got the 2 and the 3, and then we can see inside the brackets a -2 and a -3. So some students start to make the theory of just, well, find the solutions, times them by -1 and put them inside the brackets, and boom, you've got your factors. Now that's worked in this particular scenario, but you've got to be really careful because it doesn't always work that way. And that might be why, or probably is why, your teacher's not taught you about this trick if they haven't taught you about it. Because, for instance, if we have 2x squared minus 12x plus 16 equals 0, if you solve that quadratic using whatever method you like, you'll get the solutions x equals 2, x equals 4. So it'd be very easy if you're using the trick we're talking about a second ago to go, oh, well, it's just therefore x minus 2, x minus 4. But it isn't. And you can see that if you multiply the brackets out. If you multiply the brackets, you will not get the quadratic above, and that is therefore not factorizing. Factorizing is only factorizing if all the stuff we had in the original quadratic is still there somewhere in the brackets when we've factorized it. In other words, the brackets should be able to be multiplied out to get back to where you started with. So the fact this isn't happening shows this isn't what it factorizes to, and therefore it'd be incorrect to write it as such. Now, therefore, as a result, personally as a teacher, I don't recommend students going about it this way, because although there is a trick you can do to adjust what's happening when it didn't work in this particular scenario on the right, the reality is a lot of students forget that and just mindlessly start doing this as, a bunch of steps without reason, and then they just get it completely wrong. So I recommend not doing this, but if you do want to do it this way, as I said, there is an adjustment you can make. I'm not going to tell you what that adjustment is, and the reason for that is I find that if a student can work out what that adjustment is for themselves, then they understand what's going on well enough for this trick to be able to be used by the student accurately. Whereas if it's a student or somebody who can't work out what that adjustment you need to make is by themselves, then there's somebody who's not going to remember what that adjustment is in an exam. So therefore, that's my personal opinion on this approach for factorizing quadratics, acknowledging it, but also explaining why it can be flawed if you don't know what's going on properly. Okay, hopefully you found this video useful. I'll see you in a future video where we'll look at how you can actually solve quadratics using any of the main methods. And so therefore, I'll see you in that video. Goodbye.